Good morning, everybody. Welcome to our today's CMCC webinar, which is dedicated to climate change, health, and social inequalities in cities, demonstrating some findings from the Turin, which was taken as a case study. The work will be presented by Marta Ellena, who is a colleague of ours in the CMCC Foundation and a PhD student in Foscari University of Venice in the PhD program on science and management of climate change. It is her final work for this PhD program. I would like to briefly introduce to you the CMCC, which is a network of research institutions which aims at investigating and modeling the climate system and provide foresights and quantitative analysis of our future planet and society in relation to climate change. I said it is a network. We are actually 7 different research units, or more than 7 units, but in 7 places across Italy. Working with different institutions which form our network, and try to implement as much as possible an interdisciplinary work on different disciplines which are all related to forecasting of climate change and climate change impact on our society. What we are supported by a supercomputing center, which enables us to have climate model simulations running, and we lay a lot of effort also on outreach and provide both on the scientific side as well as on education and dissemination to the larger public. In our today's session, just some remarks on housekeeping. As you have heard at the beginning, the meeting is registered. So please, if you do not agree with that, you should disconnect now. It is being registered, so you can return back on it and see it on the CMCC YouTube channel. At the end of Marta's presentation, we will have a Q&A section. You can either write your questions in the questions and answers field of the Zoom program, or during the session, use the raise your hand and we will give you directly the word. Thank you. So I give the floor to Marta and enjoy the presentation. Sorry. Okay, Marta, the floor is yours.
Perfect. Can you see my screen? Margaretha, can you see my screen?
Yes.
Perfect. Okay, thank you very much. Good morning, everyone. And first of all, thank you for being here today, showing interest in this webinar. As Margaretha mentioned earlier, this webinar is structured to provide information about the temperature health nexus with a specific focus on social and economic factors, as well as on built environment characteristics. Therefore, just to give you an overview of what will be covered more specifically in this webinar, first, I will deal with topics related to urban population observation and scenarios. Then I will move to climate change and health, looking at the differences between direct and indirect effects. And then I will treat information related to social inequalities together with the climate change, with the vicious cycles between these two phenomena. Finally, more in detail, I will focus on the work that I did during the last years in relation to this methodology that is flexible and reproducible for urban areas, based on a specific case study of the city of Turin in northwest of Italy. From the initial steps, therefore, the literature review to the final one, that is a detailed diversification of the risks between the different geostatistical unit of the city of Turin, looking at socioeconomic factors as well as built environment characteristics. So, Sarah Louise-Baber, director of the World Health Organization Center for Health Development, made it clear in one of her recent speeches that while city life continues to offer many opportunities, including potential access to better healthcare, today's urban environment can concentrate health risk and introduce new hazards. This is a very important statement, especially consider that the fact that the percentage of the world population between the last year has increased a lot. In the plot in the right side of this slide, you can see the differences of the two bars, the one related to the percentage of the population living in urban areas in 1950, and the one related to the one in 2020, therefore today. And as you can see, the percentage increased a lot in this slot of time. For the first time in history, in fact, more than 50% of the world population lives in urban areas. And by 2050, it is assumed that about 70% of the world population will live in cities, in urban areas. So why cities are considered an hotspot in relation to climate change? The concentration of people, as well as the amount of economic and social activities, are much more relevant in urban areas than in other contexts. The case study I will present today is a European city of about 1 million people. Therefore, the quantity of exposed population is already very high. But there are also urban contexts where the population reaches about 37 million already. The image in the right shows the 20 largest cities in the world from Tokyo to Tianjin. And this is just to give an idea of the amount of population that can belong to even one specific urban center, and to underline also the fact that population is expected to increase not only in urban areas, but also in rural areas. In fact, in 2050, the world population is expected to reach about 9.8 billion, while at the end of the century, it is expected to reach about 11.2 billion. Therefore, more people, more citizens exposed to the impacts of climate change at the local scale. And so, apart from the urban concentration of people, what are the other characteristics that make cities particularly exposed, that make cities an hotspot? While urban areas are generally exposed to the same regional climate as the surrounding areas, the physical environment of the cities, for example, the morphology itself of a specific city, but also the social economic activities of the urban areas may alter the effect of exposure of the local scale. Build up areas in cities create, in fact, unique microclimates due to the quantity of artificial surfaces, which can bring to changes in wind directions. Let's think, for example, to wind corridor, in the influence of precipitation patterns, bringing to phenomena such as urban heat island and urban flooding. But there are also other aspects to consider, for example, the demographic, the urban production and consumption, but also the people lifestyle, because this aspect can bring to more or less emissions in the atmosphere. Therefore, cities are really important hotspot in terms of adaptation to climate change, but also in terms of mitigation. The IPCC, that is the Intergovernmental Panel on Climate Change, one of the most important scientific organizations worldwide that produce information about climate change, in the latest report called Impacts, Adaptation and Vulnerability, published a few months ago, stated with high confidence in urban environments, the impacts of climate change have already created significant damages, among others, to human health. There are several climate hazards that impact cities, and among others, the IPCC highlighted how hot extremes can impact cities more than other impacts. Another relevant aspect to consider is the fact that these impacts are concentrated on urban residents who are already more disadvantaged. Therefore, the most marginalized economically and social groups, thus exacerbating the already existing situations and inequalities at the local scale. But let's see now, what are the effects of climate change on health? The effects of climate change on health mainly could be divided in direct and indirect effects. With direct effect, direct effect results mainly from changes in the intensity and frequency of extreme weather events, such as flood, cold or heat events, but also UV radiations, while indirect effect can be felt through changes in the incidence of disease transmitted by insects, for example, vector-borne disease driven by mosquitoes, rodents, or changes in water, food, and air quality. If we consider the impacts of flood in the urban context, they are particularly harmful for the population because of the excessive runoff that occurs due to the reduced amount of vegetation that characterize the urban areas around the world. The effect that such an event may have on the human health of the population in cities may concern injuries and infection from one side, but also pollution and contamination from the other. In fact, floodwaters can contain sharp objects such as, for example, glass or metal fragments, which can cause injury and lead to infections. But also sewage overflow can be a major source of pollutions in urban areas. The Center for Research on the Epidemiology of Disasters, called CRED in acronym, publish every few years a report called the Human Cost of Disasters. I took from the last reports this image that records the total number of people affected by disaster type from 2000 until 2019. In this case, with disaster type, we refer to the natural disaster type. This is why you can see in the plot also the earthquakes. But what I found interesting here is that the 41% of the total number of people affected by disaster type in this range of time corresponds to people affected by flood, that in absolute number corresponds to 1.75 billion of people. This map, it provides similar evaluation and the size of each state varies based on the number of deaths between 2001 and 2017. Flooding kills people in every region of the world, and between 2001 and 2017, the count of flood death was higher in Southeastern Asia and Eastern Asia, where India specifically is the most affected territory from flood over the period 2001-2017. In contrast, more flood disasters happen in Malawi and in China, and the most economical damages through floods were caused in China, followed by USA and by Thailand. On the other hand, if we consider hot extremes, this can be associated with a phenomenon called urban heat island. To make it simpler, this phenomenon consists of an increase in temperatures where the percentage of impermeable surfaces is higher. This in respects to the temperature which characterize the surrounding areas. To provide you some example, I took this map produced by the Urban Climate Service Center that show the diversification of the urban heat island between the city of Milan, Palermo, Naples, and Rome. The resolution of these data are 100 meters per 100 meters, and it is clearly visible how there is a difference between the central areas of the city and the surrounding areas. In fact, darker squares corresponding to higher temperatures tend to be in the city center, while squares more towards blue color, let's say, that corresponds to lower temperatures are located in the peripheral areas. And these data are really important in order to understand how the urban heat island is diversified within the city, in order to start to understand why there is this diversification. In this case, as in the previous slides, the period under analysis is the same, 2001, 2017, but here this map produced by World Mapper, that is a really interesting map website that I suggest you to take a look, track the number of deaths due to heat waves from the same period. The highest absolute number of heat waves occur in India and Japan, followed by USA and Pakistan. But most fatalities through heat waves have been recorded in Russia in 2010, France and Italy, mainly referring to the heat waves of 2003. Now, if we consider the urban environment, it is therefore necessary to understand how these impacts are diversified at the local scale. By performing complex mathematical and statistical model and downscaling operations, it is then possible to develop local climate models and data from global and regional climate models, which allow us to understand the hazard diversification between cities and within cities. This data that could be raw or processed into indices as the one that you can see in the right part of the slide from CDI, are useful, in fact, to understand which impacts are expected due to the emission scenarios taken under consideration for in the medium and in the long term. However, to determine the risk at the urban level, there are other aspects that must be taken under consideration. For example, the social inequalities. As can be seen in this two framework produced by Islam et al., there is a vicious cycles between inequalities and climate change. In fact, in the plot in the left, the initial point of the scheme refers to the multidimensional inequalities that specifically they resulting from different factors, for example, environmental inequalities, social inequalities, or economic inequalities. The fact is that these multidimensional inequalities are making more exposed the already most disadvantaged group within the urban environment. And when a climate hazard occurs, for example, a flood, or urban flooding, or a heat wave, or urban heat island phenomena, as we saw before, the losses related to assets and income are more visible already in those groups that are already the most disadvantaged at the local scale. The similar scheme is the one in the right side of the slides, where the input is the climate hazard in this case that can bring to direct and indirect losses that also it is showing that the most disadvantaged groups are those that are suffering the most from the impacts of climate change. The study I've been conducting over the last few years, it is considering different elements from different phenomena from different point of view. I tried to list it here the sustainable development goals that refers to the study I developed during this year. And they are, from my point of view, mainly four. The first one is the sustainable development goal number 3 that refers to good health and well-being. The second one is the one that can be referred to the reducing inequalities already in presence. The third one is the one that refers to the urban environment. And finally, the last one is the one that refers to the climate actions itself. This research was structured thanks to the continuous support of different researchers, but specifically thanks to CMCC, to the IS Global, that is the Institut Global de Salud de Barcelona, and to the Epidemiological Center of the city of Turin that provide the precious data used within the quantitative analysis. The study, as mentioned at the beginning, was developed mainly in 4 steps. First, a literature review has been carried out in order to understand which are the main factors that are important to consider at the local scale, all from a socioeconomic point of view, but also in terms of built environment characteristic, indoor and outdoor. This was useful also to justify the factors and the elements that we decided to include into the quantitative study later on. Next, 3 quantitative studies were developed to understand the risk relationship that there is between extreme temperature and mortality in urban areas on the case study of Turin. For all these studies, especially for the quantitative one, we used the highest resolution data as possible. In fact, we took daily data of climate and mortality with all the socioeconomic characteristics referring to each individual of the data set. And we applied a model that is called DLNM model, distributed lag nonlinear model, that helps to take into consideration the nexus between the temperature, the complex nexus between the temperature and the health, that in this case was mortality. Therefore, the first study, structured and developed thanks to Margaretha, but also to my PhD supervisor, Stefano Soriani, illustrate how vulnerability factor, together with the hazard and the urban parameters, determine the nexus between heat and health, that we decided to call it here heat-health nexus. The study is based on a systemic literature review, and to facilitate the comprehension of all the factors that we found within the articles analyzed, we decided to disaggregate the vulnerability factors into three main factors and elements that are sensitivity, adaptive capacity, and enhanced exposure. Sensitivity here represents the personal biophysic and social characteristic driving vulnerability, the vulnerability of the individual. With adaptive capacity, we reflect the ability of citizens, policymakers, local businesses, and institutions to respond to heat stress conditions. And finally, with enhanced exposure, we represent the aspect of the physical environment that can be exacerbate or mitigate climate impact within different places of the city. In this case, we decided to classify four main categories in relation to sensitivity and adaptive capacity, while we choose to diversify the enhanced exposure in two other ones. All these factors have been chosen in detail, looking at the literature and following the World Health Organization guidelines. Here you can see in detail the classification of the categories into groups and specific reference variables. For example, if you consider asthma, it is a variable that it is included in the health status group that is part of the mental and physical health categories. On the other hand, if you consider, for example, ethnic minorities, this is part of the social status that we classify within the social categories. All the variables that have been analyzed are referenced, and the link in the slides, it is directly following you on the page where you can find the paper. In here, however, the division into category groups and variables is given on the basis of the division between indoor and outdoor environment. As you can see, for example, building standard is a groups that correspond to both category indoor and outdoor, but the variables that are part of these groups are different. For example, for the indoor environment, we took into consideration and we included air conditionings and the type of cooling system, while for the outdoor environment, we considered building status as well as the direction of the window front, for example. The second study, that is the first quantitative study developed during this research, considered the city of Turin. Just to recap, the city of Turin is in the northwest of Italy and is part of the Piedmont region. It consists more or less of 1 million people. Daily data of climate and daily data of mortality have been merged together in order to analyze the diversification of the relative risks of all these groups taken into consideration, divided by gender, therefore men and women. All the estimates have been calculated using DLNM, a standardized quasi-Poisson regression with the inclusion of DLNM module. And what did the results show? First of all, the relative risks was higher in all the subgroups referring to women instead of men. Elderly, as expected, are the ones most exposed to heat in the urban area of the city of Turin. In regard to marital status and number of household occupancies, it results that the relative risks is higher for those people that are characterized by more social isolation, therefore people living alone or people widower. While in relation to education, the situation is more complex. Relative risks, in fact, were higher for women among the less educated groups, but higher in men for the most educated groups. Therefore, to understand this, it is necessary to take into account two phenomena. The first one is that individuals with lower education are often associated to premature death. Therefore, death attributable among older men can be associated to higher level of education. The second phenomena that I would like to mention is that there was a wave of migration from the south within the city, because Turin is the base of the automotive Italian industry called Fiat. And these different ways of migration over the years created a social stratification. Men from the south were often associated, in fact, with lower education, condition that makes them more suitable for a premature death. And this, it is linked to the point of before. Again, also in this case, in case you want to read the specific of the model and to see the discussion of the results, the link is provided in the slide. The third study, now under review, is based on a 37 years time series analysis as the one of before, starting from 1982 to 2018. The model applied here is still a standard quasi-Poisson regression with the inclusion of DLNM, but the research question here was different, and we also include the cold here. We wanted to understand how the trends in cold and heat attributable mortality risks divided by the different socioeconomic groups considered in the analysis, it is varying over time. In here, we apply the same model, but to data subset of 25 years of moving periods in order to see how the relative risks, together with the attributable fraction of mortality, shifted over time. In general, the results show how the same evaluation of the paper estimates of the paper of before, but the added value here is to define is that irrespective to the method applied, in fact, we used 10, 15, 20 years moving period, as well as other models such as time varying DLNM that are all reported in the sensitivity analysis of the paper. The general trend that came out is that there is maladaptation within the Turin population. Therefore, that means that the population of Turin does not seem to have adapted to climate change, especially to extreme temperatures of climate change for cold and heat conditions. Finally, the latest work, which is still under development, analyzed the spatial distribution of these relative risks between neighborhoods, there are in particular 23 within the city of Turin, but also districts that are in particular 8 for the same subgroups of the population mentioned before. This step will allow us to establish cold and heat attributable mortality risk diversification within the city in order to understand how the different socioeconomic groups behave in relation to the risk to the urban level. Now, we are in the phase where we are including in the model information about built environment characteristics such as green areas or artificial surfaces, quantity of water, but also other information that probably are under consideration right now, like pollution, PM10, PM2.5, and O2 or CO2, and to see how this built environment characteristic can influence the relative risks that we can see at within the different areas of the city. In fact, as stated in the last report of the World Health Organization about social environmental inequalities of Europe, it is really important to start from the most disadvantaged group in order to identify the most effective adaptation options at the local scale. And this relates, among others, to the vicious cycles that I mentioned before between climate change and inequalities. In the general scientific context, these studies are in the initial phase of the adaptation processes. In the left part of this slide, you can see the schemes produced by the Ramses project, that it is a project that as an outcome produced a toolbox where you can see the different steps to follow in order to understand which adaptation measure to undertake on the local scale, but also how to evaluate and monitor them in order to take the most effective and efficient choices in terms of adaptation for the long-term perspective. In order to achieve an adequate level of adaptation, it is important to do a stakeholder engagement of the local, but also of the international stakeholders. So it is important to involve in the process citizens, researchers, health policymakers, other policymakers, not referring to the health sectors, but also local businesses, in order to reach a good level of adaptation, but at the same time to increase the awareness in relation to mitigation. Therefore, this analysis from my point of view, it could be useful in order to understand how the risks is diversified within the case study of the city of Turin. But in general, this methodology, I hope it could be reproducible to other contexts, because the step that I showed you before can be reproduced also in other urban areas that can have completely different sites. In here, you can see the references that I used to produce this presentation. But in case you would like to know more information about the detail of the model, feel free to contact me also next days. Thank you so much.
Thank you, Marta. Thank you for this really inspiring and really interesting presentation on a problem which is burning and is felt by all those who are dealing with climate change and the climate change impact on urban areas, which is where the fact that climate change does not have the same impact on everybody is increasingly getting to the consciousness of policymakers. And it has, for instance, been underlined strongly in the last IPCC report of Working Group 2, which has been presented at the beginning of this week, this month. Among the questions, there's one generic question which goes, everybody wants to see your presentation. I would say you can see it on the YouTube channel of CMCC. So go to YouTube and search for CMCC video, or go to the CMCC website and watch again the presentation. So you have not only the slides, but also Marta's comments and explanations, which is more than only the slides. There is another question by Enrica, who writes, thank you, Marta, very nice. Isn't mental health an outcome variable of morbidity resulting from exposure, vulnerability, and hazards? Do you track, and the second question, do you track people over time? I guess I'm suggesting to extend your work from mortality to morbidity. Please, Marta.
Thank you for this interesting question. I'm not sure about the first one. Is it related to the fact that mental health is considered as an outcome coming from extreme events? Or okay. During the systemic literature review, we took all the variables that consider the nexus between built environment, sensitivity, and health, and we analyzed how these factors were included into the analysis. So mental health, for example, in this case, it was categorized as sensitivity variables, because people that are affected by mental health disease during heat, for example, during a heat wave, they are more affected. They can be more affected by that impact because of their mental conditions. So it seems like we can see the paper that we took that information was saying this kind of thing. But actually, you are right, because mental health is also an outcome coming from the climate change impacts. In fact, this is an indirect effect that I included within the slides of the effects of climate change, direct and indirect. And it's actually one branch under research and under development. And the Scandinavian countries are doing a great work in Europe in relation to this topic. About the second question, I was not sure at the beginning of my PhD if it was the good choice to take into consideration mortality or morbidity. Actually, I decided to start with mortality because the data set that that the epidemiological center of the city of Turin has the longest time series in Italy that they did record linkages between mortality and all the socioeconomic information of the individual from the actually 1972 to date, but we used for some issues just the time series from 1982. While the mortality, the hospitalization, for the morbidity, such as the hospitalization, are just available from the 90s. So also in terms of approaching this model, I decided to start with mortality to learn the process, but actually it will be really interesting, and it's something that we are considering with another PhD student that is working with us to continue that work also with hospitalizations.
Thank you, Marta. Another question is, do you plan to consider involving remote sensing data to reveal the spatial characteristics of those aspects you studied?
Yeah, this is a really interesting question too. Actually, we are considering, I started to consider to take the shapefile of the city of Turin, that the geoportal of the city of Turin is really rich in terms of shapefile related to the built environment. I started to divide this information for the statistical units, geostatistical units I want to consider. But I will consider for sure the data that are available on the Copernicus platform. So I'm starting in this month to build the table to where take data in order to include the built environment characteristics in the next few months. So I think we can consider to include in the model also remote sensing data if there is not an overlap with the data that we already have.
Thank you. And another question, do you have a dedicated health indicator that allows you to link the climate warming with mortality and morbidity? I'm referring to an indicator allowing you to consider climate warming as a cause of mortality and morbidity.
Okay, I suspect here that the question is if, as a climate health indicator, if we refer to climate indicator itself, we decided to use mean temperature because we also use maximum temperature in order to analyze the heat, not the heat and cold, of course. We also used maximum apparent temperature or apparent temperature, but we did not see differences. So based on the literature already available on the ground, we choose to go with the mean temperature. If we refer to health indicators in relation to heat, we tried to include respiratory disease and cardiovascular disease into the analysis, but it was the quantity of data was not so high, therefore the model could not fit adequately the relative risk curve. Therefore, we decided not to include them at this stage.
Okay, thank you. And I think a last question also, because I have a background noise I cannot eliminate. Which type of concrete actions can the local level enhance in the case of Turin, for example?
Yeah, this is a really interesting question too. There are several actions that can be taken at the local level. And actually, I did not focus so much on these adaptation options due to the fact that the choice of the adaptation options and measures will be taken at the last stage of the research and will be suggested at the last step of the research. But actually, there are a lot of actions that can be undertaken. For example, in France, if I'm not wrong, they started to have a data set of people that are the most vulnerable in neighborhoods, and people that wants to be a volunteer can subscribe to this program and help the most disadvantaged group in the neighborhood. For example, people very old or people that have some problems, especially related to heat. These volunteers can help them with everything that they need during the heat wave period. This is just an example. Another program that has been carried out in Italy after the 2003 heat wave was a national program where the basic doctor that refers to each individual at the local scale could support. They had to do a list of the most vulnerable and be sure and call them during heat waves in order to see if these people were okay or if they need some help. These are just two examples, but there are many. For example, other physical adaptation strategies that can be that we could think about are the green roofs or the green walls, the inclusion of it. The literature is talking about rainforest cities, as it is happening in Milan. Yeah, these are just some of them, but we could like do a big list of things. But the important thing is to define which are the main risks and how they are diversified within the local scale, and then choose how to act in order to mitigate the mortality and the morbidity during extreme events that in this case is temperature, but they can be also urban floodings or others.
Yeah, thank you, Marta. I think this is among the most interesting activities those you were mentioning, where it is there's not only an alarm giving and heat alarm, which is diffused after the 2003 heat waves in Italy as well as in France and in other countries, but also an active getting into contact with those people you know who are more vulnerable, and checking that they are okay and supporting them with their everyday life, including taking care that they're drinking enough. Okay, thank you. I think we need to close now. I would invite those who asked for the slides to look at the YouTube video. You can stop it at any point and get down the references Marta provided, or write directly to her. And I would like to invite you to follow our next webinar. Wait a second, I hope I can find it now. Which will take place on the 30th of March and is dedicated on how to get the public on board with climate reforms. It is at 3 p.m. on the 30th of March. You can find the links for subscribing and participating on the CMCC website. Thank you for all for having participated. Thank you very much for Marta for presenting this very interesting work. And looking forward to seeing you in the next occasions. Goodbye.
Thank you very much. Bye-bye.
Goodbye, everybody.